Good morning. My name is Sol Milne. I'm a postgraduate researcher at the University of Aberdeen working with David Burslam, and today I'm going to talk to you about the work we've been doing at the UNDP project on orangutan population densities and the methods we've used, the results we've had so far, and our recommendations for future monitoring of the project landscape. So we're going to talk about the use of drones for surveillance of large areas of forest, and also key aspects of the projects that I'm most interested in. So individual orangutan nest counts, strangler fig densities, and the effect of land use type on these variables. So thank you for your time, and I hope you find this presentation useful. So as a bit of background on the project area is approximately 260 kilometers squared, so it's a very large area. And within that, there are multiple land use types, such as mixed mosaic planting, oil palm plantations, rubber plantations, acacia, as well as Class 1 protected primary forest and secondary forests across a wide gradient of degradation. So in order to monitor this landscape effectively, we have to use an efficient surveying method, which is why we've opted to use drones. So far we've surveyed 50 kilometres squared of the landscape, which constitutes about 20% of the whole project area. That means that's 33 individual plots, each 1.5 kilometres squared, spread about the landscape across all different land use type and across a gradient of forest degradation. So when we do these surveys, we do myself and 5 research assistants from SERP and now with Forestry. We firstly begin with a line transect on the ground. We walk 1.5 kilometers on the ground, marking every 50 meters, and we look for any orangutan nests we can see. So when we find a nest, we record the species of tree that it was made in, the height above the ground, the class of nest, how old it is, and we use information to figure out how number of nests per unit area, which we then use to find out the number of individuals per kilometre squared. In order to do this, we have to incorporate what's known already about Bornean orangutans in terms of the number of individuals within a population who build nests and the decay rate of the nests themselves as well. So once we incorporate this information, we can figure out how roughly how many orangutans are per kilometre squared in different forest types across the UNDP landscape. So we do this first ground transect initially, and we follow it up with an aerial survey. So the aerial survey we do using drones. Now most of the project's area had been surveyed previously in 2014 by WWF with the help of spotters on either side of a helicopter. They used to count the number of nests they see, and from that they work up a population density based on the number of nests they can see during several flights over the area. In this case we're using drones, so drones are a fraction of the cost of using a helicopter, and you can program them to go in any area you like of the project landscape. So what we've done is blanketed the area we survey on the ground with a 1.5 by 1 kilometre squared area we survey aerially. So in these surveys we look for firstly orangutan nests on the top of the forest canopy, and we also look for strangler fig trees. Now strangler figs are particularly important in a kind of fragmented landscape like this because they have high amounts of sugar, calcium and fats and protein, and they also fruit relatively frequently. And that's important because in kind of lowland dipterocarp forests, fruiting events, large-scale fruiting events are rare, and so animals like orangutans really do depend on tree species that fruit more frequently. So we conduct these surveys not only on different land use types, but also over a gradient of forest degradation. There's good quality primary forests and there's poor quality secondary forests, recently logged and recovering. So we need to analyse the thousands of images we get from these drone surveys independently and without the biases you would expect when looking at poor quality forests. So our way of doing this was to put a page on the website called zooniverse.org. This website allows us to upload all our images, teach volunteers how to search for orangutan nests and strangler figs, and then use independent observations made by volunteers all around the world to find strangler figs and orangutan nests that we would otherwise miss in our own independent surveys. So currently we're going back to the field and using the data given from this survey in order to verify the accuracy of observations by citizen scientists from around the world. So each image is analysed 5 times by 5 different volunteers, and we consider every image that's been selected by a volunteer and then go back into the field and determine the accuracy of their selections. So now I'm just going to run through the results we have so far and my interpretations based on the data we've collected. So this is data in its raw form, and we're still doing analysis on the relationships between the variables that we've been studying. So this is what we have so far. So this is the first graph showing the relationship between the density estimates determined from aerial surveys and those determined from ground-based line transects. So ground-based line transects look at a very small area, literally as far as the eye can see when you're walking through the forest, multiplied by 1.5 kilometers. So this means that when we find a nest during the line transects, we get a higher density estimate than we get from drone surveys. Drone surveys look at a 1.5 kilometers squared swath of forest. Therefore, when we do find nests, we're multiplying a small number of nests by a very large area, so you'd expect to have the density estimates from the air to be lower than density estimates determined from the ground. However, a lot of the time, the survey areas which didn't yield any results from the ground yielded results when we surveyed from the air. So this presentation will kind of explain why that is. So when we conducted our ground-based line transects across each land use type in the project area, we found that in most of the transects we didn't encounter orangutan nests. So an important distinction to make is that in ground-based line transects, the area you're surveying is only as far as the eye can see in the forest, which is about 20 to 30 meters max, plus the 1.5 kilometers we survey during the transect. So as a result, we're looking at a very small area compared to the aerial survey conducted by the drone. So the highest density of nests that we discovered were in low quality forest at low elevation with high densities of fig trees. So it's this kind of combination of factors that seems to be consistent throughout each land use type. An interesting effect of using drones was that areas that had been surveyed on the ground and didn't show orangutan nests showed nests when we surveyed them aerially. We're surveying a much larger area, and as a result, when we looked through the images, we still found orangutan nests. So we're getting different density estimates from the ground compared to from the air. This is partly due to having a much larger area surveyed, and it's also due to the fact that we're looking for more obvious nests on top of tree crowns. However, our results are consistent. Low quality secondary forest with at low elevation with high amounts of fig trees seem to be the favoured habitat type for orangutans in the UNDP landscape. So far we've encountered strangler figs across every land use type that we've surveyed in the project area. Notably, in primary forest there is a high density of strangler figs. However, these areas also exist at higher elevations, which may be a reason why we are finding fewer orangutans here despite the presence of food. In areas earmarked for oil palm conversion, there is also a presence of strangler figs. However, this is low quality forest, so we have found fewer orangutan nests here than in other areas. However, there are still orangutan nests present very close to oil palm plantations, particularly Serinjaya, so it's important to note that these areas are an important habitat despite the quality of the forest. Now this graph shows a relationship between strangler fig density per kilometre squared compared to aerial orangutan density across all land use types. Now this relationship is positive, but it's a very weak correlation. However, what we think is that there's going to be a strong effect of land use type. So where there are fewer trees and therefore higher costs associated with dispersal, there's going to be fewer orangutans despite the presence of strangler figs. Also, in areas such as primary forest, where there's a high density of strangler figs, but also at a higher elevation in the project area, there's also going to be fewer orangutan nests. So this relationship has been shown to be positive in previous studies in Borneo and Sumatra. However, in the UNDP project area, it's going to be highly dependent on the health of the forest in each specific land use type. Now, we found this relationship between elevation of the survey area and the density of orangutans to be fairly consistent both in ground-based and aerial surveys. However, quality of forest is going to play a part here as well. However, the highest density of orangutans we've encountered so far have all been at altitudes of less than 300 meters. So based on this survey, I would anticipate that lower elevation areas with high quantities of figs are going to be the most useful orangutan habitat in the project area, and therefore most important to conserve. Interestingly, we found there is a positive relationship between the elevation of the survey area and the number of strangler figs we find. So areas with higher numbers of strangler figs generally at higher elevations. However, elevation plays an important role here because orangutans are less likely to be found at areas of higher elevation. So it seems as though elevation is a very important factor in finding areas that are conducive to orangutan survival. Thank you for your time. Please get in contact if you have any questions about the survey or the methods or any aspects of the project. We're projected to have this fieldwork finished by the end of the year, and I think that continued monitoring of the area using this method would be useful, and especially as the output of this project has been very useful in terms of a pilot study to see how close-range drone images can be accurate for surveying for orangutan densities, but also for seeing how Zooniverse and citizen science can be utilised for conservation purposes. So, yeah, thanks for your time, and get in touch.